This is Chapter 14 Review. We are going to look at a concept map to tie all the concepts together for the chemical reactions. Keywords are going to be circled, and then I will include linking words to show the connection and include some explanation of some of the topics. So we have chemical reactions. Chemical reactions happen and show evidence by different ways. Now remember, it's not the all or none rule. It could be one of these ways that will show that there's been a chemical reaction. So evidence includes gas being released, and this can be in the form of bubbles. Remember the bags that we did our chemical reactions in and they expanded. Color change. Again, our baggies that we did changed from a red to like a hot pink to a yellow, showing us a chemical change. Temperature change. Again, our baggies showed evidence of this, and we'll talk about the two methods of temperature change in a second. We can also include odor and also the precipitate. And remember, the precipitate is going from combining two liquids or more that result in a solid that falls out of solution. And the good example that I always like, reminds me of this, is cottage cheese. You get that solid that forms from mixing the milk and other substances together to get your cottage cheese. Going back up to the temperature change, there are two types of temperature changes that occur. So you have your endothermic, and I write this in blue just because endothermic, endo means in, thermic means heat, so in, heat, heat goes in to the reaction, therefore feeling cold. So it goes into the bonds of what is being made, so therefore you do not feel the heat being given off like you do in exothermic. Exo means out, therm is heat, so heat is released, feeling warm. Now when you look at the endothermic and exothermic reactions, they can be identified via a graph. We talked about the graph as you start with your reactants, and then you have your activation energy, and then the exothermic, you're going to have less energy in the products. So reactants and your products. So when your products have less energy than your reactants, you know that heat was released, and that's an exothermic reaction. Whereas when you look at the endothermic, you have your reactants and your activation energy, but then your products have a higher amount of energy because that energy had gone into the products. So heat was absorbed. Okay. Chemical equations are used to express chemical reactions. Chemical equations are a shorthand of showing you what's happening in a chemical reaction. So the parts of a chemical reaction include your reactants and your products. The reactants is what you start with. And we know the reactants are different than the products, and the products are what you end with. And the difference is that the products are rearranged. And this is done because bonds break in the reactants. And new bonds are made in the products. Now, the key thing with the reactants in the products is that they must be balanced. And this is due to the law of conservation of mass, which basically states the amount that you have on the left side of the reactants should be the same as what you have on the right side of the products. Okay. So we are balanced by using coefficients. These are the numbers, remember, that you put in front of your molecules to tell you how many that you need. Now, the subscripts are the little numbers that tell you how many atoms. We do not touch those. You cannot change those. Otherwise, remember, it changes what the substance is itself. And it's not the substance that you're changing, it's the amount of the stuff that you have that needs to be the same. So this entails the information for chemical reactions. I'm going to continue on to a next slide to talk about nuclear reactions, so we have plenty of room to write. Nuclear reactions. Nuclear reactions happen because the proton number and neutron number is unbalanced. And this makes the element unstable. So the whole point is every element wants to become stable. So in order to do this, it will go through and decay. So to become stable, the element decays. And it will decay until it becomes stable, and sometimes it will go through alpha, beta, or even gamma decay, depending on what the element is. So the decay happens in a half-life. And remember, our half-life is half of the atoms decay over a certain amount of time. Well, these elements that do this are called radioisotopes. And each radioisotope has a different half-life. Okay. We saw this with the straw activity and the online activity that we looked at with the decaying atoms. So if we start with 100, its half-life is what it will be to take it to get to 50. It may be 100 years. Another element, so element A would be 100 years. Element B may be 1,000 years to get to 50. Each element is unique in its own half-life of what it takes to get there. Now the half-lives, the longer the half-life is, the more dangerous it is. That means that it stays unstable and radioactive longer. So therefore in the medical field they use very short half-life material for medicine, because you don't want long exposure to that in your body. Okay. So when you have unstable atoms, they will go through, and I'm going to make a line out here. There are two ways that they go through this, is fission and fusion. Fusion, when you fuse something together, you take two things and make them one. So you combine two things to create one, and this releases lots of energy. And this occurs in the sun. So this happens, and lots of energy in the form of heat and light are given off. Fission is our other one, where you take one and you split it into two, and given off is energy also. And it takes a little neutron to hit into that atom to make it split. So once it splits, another neutron is given off, which will hit another atom, which then will split that one. And then this one gives one off, and then will hit another one. And this is a chain reaction, and you will end up with tons and tons of atoms splitting all at one time, giving off energy each time, giving off a lot. And this is used in nuclear power plants to provide our power. And we used uranium typically in your power plants. So this entails the nuclear reactions portion that we covered. Make sure you review all your notes. Read through the chapters over the sections. Focus on the key topics and terms that were circled as we went through, and be able to apply this information.